inequalities. So previously we did what? We did equations, you remember?
Yes.
Equations. So with equations, the word equation comes from the word equal. That means we were dealing with the equal sign. So it was dividing sides into two. We had two sides when we were doing this. For example, if I had 3x minus 4 is equals to 0. Here it was simple, I was going to transpose. So what this meant is that the two sides are equal. But now we are having what we call inequality. That means it is not equal. We will be dealing with this sign is greater than anything that is this side is greater than anything on this side. You check where there's the side that is bigger. It is telling me that that side is big in terms of size. Even if it's x and I have 2 this side, it means x, whatever value I put here, must be bigger than 2. If it's 1, it is no longer true. And then you can have the sign of less than. It means x should be less than 2. Again, remember x can be any number here. It will be a variable. That means any number that is greater than 2. Another thing you can have is x being greater or equal to 2. It means you can pick any number for x, but it must start from 2 because it can be equal to 2. Or it can be greater than 2. And another one is x is less or equal to 2. So just to see the rules applied here, when I have, let me start with a number. When I have 4, it is true that 4 is greater than 2.
Yes.
Very true. If I divide both sides by a positive number, for example, I divide both sides by 2, the answers I get will be 2 is greater than 1. This is still true, right?
Yes.
That means by dividing by a positive number, I did not change the inequality sign. It still remains true. How about if I divide by a negative number? Let's see. I divide by a negative number, so 4 divided by negative 2, and then 2 divided by negative 2. The answer here will be negative 2, and the answer here will be negative 1. Which one is big? Which negative 2 and negative 1? Negative 1 is big. Because if I have, in my bank account, I have negative 1 rands, and someone else has negative 2 rands, I have more money than them. For me to have 0, 0, I need 1 rand. Or not, they need 2 rands. That means this inequality sign is not true. Because I divided by a negative number, I needed to change the inequality sign so that it can face the other side. And when you change it like this. So I'm having 4 greater than 2. I'm dividing by a negative. I don't divide immediately. If I divide like this already became negative 2. And if I divide like this already became negative 1. But the inequality sign is wrong. That means when I divide by a negative, what I should do is to recopy the question. So I'm going to copy the question again. I will say 4, and I change the inequality sign. Then I can divide by negative 2. Such that this is negative 2, and this is negative 1. Already, the negative 1 is greater than negative 2.
Yes.
Then you can simplify it and say negative 2 is less than negative 1. You see what is happening?
Yes.
The same thing happens when you multiply by a negative. So adding both sides, subtracting both sides does not change the inequality sign. It only changes when you multiply or divide by a negative number. You get what I'm saying?
Yes.
So let's check this example. They say solve for x. So I want to solve for the x there, the x value. I'm applying the same rules I applied when I was doing equations, when I was solving for x in equations. But the only difference is I am aware, I'm very conscious that if I multiply by a negative, the inequality sign must swap. If I divide by a negative number, the inequality sign must swap. But what I mean is, not this. You say this. If I multiply, I will say 3x. 3 multiplied by negative 3 is negative 9. I multiplied by a negative here, you see that?
Yes.
But I don't change the inequality sign because I did not multiply both sides. It only changes when I multiply both sides. So this will still remain true. So I will still say 3x less than 4 plus 9. then 3x, and then I'll continue from there. So 3x will be, this is 13, divide both sides by 3, and then x will be less than 13 over 3. You can take it to the decimal point. So let me solve this one. The answer will be 3x minus 4. Okay, I'm actually repeating the question. It will be 3x, so I transpose the 4.
Yes.
And then what do I do next?
3x.
I divide both sides by 3. So since I'm dividing by a positive, I don't need to recopy the question, and be careful. There's not going to be any changes. So x will be greater than 4 over 3. And in decimal point is what?
1,3.
So 1, or you can say x is greater than 1,3. You round it off to do decimal place if it is continuous. And then what was question number 2 that we had?
4x.
It was
4x plus 5 is less than 3.
4x plus 5 is less than 3. First thing you do, what is the first thing you will do? You will transpose, right? Transpose what? 5. So you're going to have 3 minus 5. So 4x is less than -2. Correct?
Yes.
Then you will divide both sides by the 4. -4 positive? Positive. They cancel on the left. Then -2 over 4. What does it become? -half or -0,5. So check. I was having a negative, but I divided by a positive, so I don't change the inequality sign. But if I had divided by a negative, I was going to change the inequality sign. You get what I'm saying?
Yes.
An example is this. If the question was like this, if the question was 5 minus 4x being less than 3, how I was going to solve it, I was going to transpose the 5 and have -4x less than 3 minus 5. Then -4x less than -2. Then now I need to divide by -4. I don't divide here. Why? I need to change the inequality sign. So I'm going to say -4x, I change the sign, -2, then divide both sides by -4. Then this cancels, I'm left with x is greater than half. You see what I'm saying?
Yes.
Okay, let's see a double inequality, number 3. What does it say? 4 is less than x divided by 3 plus 3. Less than 50. So here we are having 2 inequalities. What we do is we make sure that there is only x in the middle. So we remove everything legally to both sides. What you were going to do to the left, you do it also on the right. So first thing I do, I can't remove this 3 on the denominator. I start with the transposition. So I'm going to say 4 minus 3. X over 3. 15 minus 3. So I minus the 3 both sides. And then this becomes 1. X over 3. And it becomes 12. Then I multiply both sides by 3 to remove this 3. So I multiply this side, and also the middle, so that it can cancel. And then I'm going to have what? 3 is less than x, which is less than 36. And then this will be your answer. Right? Proper. So those are inequalities, guys. It's proper.